Thank you, Raluca, and welcome everyone. Great to see so many faces here. So let me give you a very brief context about what we are going to do here and why we are going to do it. So this is a second RISE camp, and RISE Lab, as you know, it's almost a 2-year-old lab. It started in January 2017. And the main premise of the lab is that to get value of the data, you need to make decisions on the data. And in order to maximize the decision's value, you need to make decisions which are intelligent, which are real-time, which are secure, and which are explainable. And there are many, many examples of systems. So as a result, the goal of the lab is to develop open source platforms, tools, and algorithms for real-time intelligent decisions on live data which are secure and explainable. So now, this camp will not be about everything here. What this camp is about, we are going to show you a tutorial for 6 systems which address 3 challenges. One is scale, one is complexity, and the other one is security. So let me start with scale. As everyone knows by now, the Moore's law is dead. Everyone is saying that, so it must be true. However, if you are looking at the computation demands for the data, they are increasing exponentially. They are increasing faster than ever because the data is increasing faster than ever. So this means that the demands for just processing the data outstrip the computation demands, the growth of the computation demands. Now, if you want intelligent decision to make on this data, that's even more computation demand. And if you want this to be also real time, you have less time to decide and do this intelligent decision, so it's even more computation demand. And finally, if you want security, security also means more demand because there are additional algorithms to protect privacy and so forth, which are going to incur an additional overhead. So fundamentally, you have this exponentially increasing gap between the demands in terms of the processing of the data, of the new applications, and the computing capabilities. So what is the solution here? Actually, there are not many solutions, as you already know. The solution is to do distributed computing, so use more nodes, and use specialized hardware, right, which is going to be faster and for particular workloads. So the second challenge is complexity. More and more of this today application, we are talking about AI application, but really more and more of today application are going to incorporate AI. And this is, you see this everywhere. So the challenge here is that when you are talking about AI applications, you are talking not only about this training, you are talking about high parameter search, you are going to talk about model serving, simulations, and obviously data processing, and many more. And today, because these workloads have very different characteristics, what you are seeing is that you are seeing to develop different systems, different distributed systems to support all these, each of these workloads. So you have a very complex machine learning ecosystems, and the complexity of this ecosystem is just growing. And what is the challenge here is then the challenge is that to really build an end-to-end application, AI application, we need to stitch together all these disparate systems. And this means that you are going to get with an end-to-end artifact, which is harder to manage because you need to manage different systems. It's harder to develop because you may have to develop different APIs. And also, it's coming performance-wise may be slow because you need to move data between the systems, and the systems may store data and operate on data in different formats. So a solution here is to provide and to build unifying frameworks to support all these workloads. So we have a one-stop shop to develop all these end-to-end AI applications. There is another dimension of the complexity. The main artifact of any AI application is a model. And building models and stitching them together in pipelines is very hard, and building such pipelines for real-time decisions is even harder. So why it's hard? Because there is a lot of processes and a lot of you need to go through in order to develop successful models. It starts with getting the data, raw data, cleaning the data, then exploring the data and getting some insights, And this also involves, again, interactive querying the data, visualizing the data, and then once you got kind of a grasp of what the data is and you know what your business problem is, you are going to design the model. And once you are going to design the model, you are going to train and you are going to figure and to validate on existing data or past data. And also you may start using data from the real deployments. And then you go back. So again, this is a complex process. And what is hard here is going that all these components happen in isolation. They are implemented by different teams in your organizations. So our solution here is about to provide a platform to holistically annotate and track data experiments and models so that it helps you with reproducing the experiments and it helps you with understanding the models, introspecting the models, understanding the connection and the relation between the data, the models, and the decisions you are going to make on them using those models. The final one, the final challenge is security, and this is becoming really a table stake, right? It's like, you know, GDPR in Europe, and you hear that every day. All this, you know, Google, Facebook, right? Privacy is a big concern, and it's a bigger and bigger, and will be bigger and bigger in the future. So, but fundamentally, it's like you have this kind of tension between developing good application, making great decisions, and building great models, and this requires, as you know, more data and diverse set of data. So how is the tension between getting that data, which its span might be different, multiple organizations, and certainly different users, while maintaining the privacy and confidentiality of the data and the privacy of the users. So the real challenge here is to do all of this. On one hand, to train the models and to query the data and to authenticate, authorize the users while maintaining the privacy and confidentiality of these users. So the solution here, and we are going to talk about some systems we build to query data on confidential data, and also we are going to talk about a solution for distributed authorization. So this is a RISE stack as it is right now, and it has 3 layers. There is a platform, there is an execution layer, and there is application layer. We do a lot of work at each of these layers. At the execution layer, these are the computation frameworks we are building, which are going to operate on the data, to build the models, to train the models, to perform experimentation, and many more. Then is a platform. As a platform, we are going to have not only the storage layers, the storage systems, which we are going to use to persist the data, to read the data, but also it's a lot of, we build a lot of systems for providing security. And some of them are here on this slide. And I'm not going to go through all of them because it will take me more than I have. And finally, application. Application, we are working closely with many of our partners, industry partners, and other labs in Berkeley to actually validate our designs to support this kind of, some of them are great applications. Actually, many of them. So I told you that we are going to go through 6 systems which are going to address this, which address some aspects of the challenges I mentioned to you, which are scalability, complexity, and security. So the first systems you are going to hear about, and you are going to go through the tutorial, it's Ray, and the Ray is a unified platform for distributed AI applications, and it's designed to tackle the scale and the complexity challenges. And as a part of Ray, or on top of Ray, we are going to also learn about a few libraries. One is RayTune, which is high parameter search library. The other one is RLib, which is reinforcement learning library. And finally, you are going also to hear about these new systems. Modin, which basically is today running on top of Ray, and what is provide a distributed execution of Pandas, the very popular library for data processing and data analytics, which you have in the Python ecosystem. This is the first system with this set of libraries. The second system you are going to hear about, it's Clipper, and this is a modular, scalable inference system. It addresses a scale challenge on the inference side, which you know is very important. And the third will be Floor, which is this system which provides you the ability to track and automatically annotate data, models, and experiments so that you can have reproducible experimentations and get and helps you to better understand the models, the relation between your models, data, and the decisions. Tomorrow, you are going to hear about 3 other systems. One is Pyren. It's a serverless execution engine for scientists. You can use it for data processing, and you can also use it more recently. We have a library, NumPyren, for linear algebra. It's very exciting, very easy to use. And we are going to hear about 2 security projects. One is Opaque, which allows you to make queries while maintaining the privacy of the data you are going to query. And this is an extension. It's built on top of Apache Spark SQL. And finally, you are going to hear about Wave, which is a decentralized identity service. So just to provide you a little bit more layout of the land, and this is what will happen in the next 2 days. Today, after my talk, you'll hear more about what the tutorials are about. And then, like I mentioned, you are going to have 3 systems today, Ray, Clipper, and Floor. And tomorrow, you are going to hear about 3 other systems. And at the end, you are going to have one of these applications is going to be end-to-end, which is going to use multiple of the systems we've been developing. So finally, if you have any questions, and also I want to use this also to thank our wonderful staff, which makes all of this possible. Kat, Boban, David, Shane, John, and Jay. So please also join me to thank them for making all this event possible. And finally, I'd like to thank all our sponsors again, because we are here because of them. And we hope that during these tutorials, we are going to, not only you are going to get a taste of what we are developing firsthand, but also this is going to spur new collaborations, both on the systems we develop and on the applications you hope to use the system for, your application. Thank you.